Today's notes will focus on slope and slope-intercept form. So for our objective for these notes, we're going to be finding slope from a graph or 2 points, and also writing and graphing equations in slope-intercept form. So kind of a lot of things all together. So to begin, slope is the measure of the steepness of a line. It's the ratio, which is a fraction, of rise over run of the change in y over the change in x. So it's the vertical distance over the horizontal distance. So rise over run is a great way to remember that. You know, rise is your vertical, run is your horizontal. There's also a formula to use when you know 2 points, and that's y2 minus y1 over x2 minus x1. It's essentially the difference in the y values, which is the change in y, over the difference in the x values, or the change in x. You'll also see this written potentially as delta y over delta x. Delta is a Greek letter, which usually symbolizes change in this instance. So change in y over change in x. Now there's 4 basic types of slope you can have. A positive slope, where your line goes up to the right. So as x increases, y also increases, so they're both increasing, right and up. A negative slope, where you're going down to the right, so as x increases, y decreases. We can kind of show that, you know, as for positive, as x increases, y increases, and for negative, as x increases, y decreases. Now a zero slope is going to be a horizontal line. That means as x increases, y doesn't change. So there's no change in y, so the change in y is 0. And for no slope, or undefined slope, you would see a vertical line because x doesn't change. This is also undefined, you'll see as well. So those are the 4 basic types. So we're going to identify them from a graph and from 2 points. Now when you find slope from a graph, you want to find the actual number, the value of the slope. You can't just say positive or negative unless you're specifically asked for that. You need to find the actual value. And so to do that, we do find rise over run, the change in y over the change in x between any 2 points on the line. Helpfully, these graphs are marked for us. So this first one, we have 2 points already marked on the line. So between those 2 points, we count up, and that's a rise of 2. And then we count over, and that's a run of 1, so 2 over 1. And you can reduce that, simplify it to 2. All right, so your slope is 2. For the second line, and you always want to go left to right. You want to try to jot that down there, because then you are consistently getting the correct sign on your slope. And we know that our line for the first example here goes up to the right, so it's positive, but you can also get that mathematically. Both the numbers were positive, positive 2 over positive 1, so the answer is positive 2. For this one, we're going to go left to right, so we have to go down from the first point to get to the second point. So that is a rise of negative 2. And then the run is 3. So our slope here is just the fraction negative 2/3. Keep in mind that you could do this with any 2 points. So let's say we picked this point and this point. So here would go down 1, 2, 3, 4, and over 1, 2, 3, 4, 5, 6. And that would still reduce to negative 2/3. I'm not sure about the shape there yet, negative 2/3. So no matter what you get for the slope, it should be the same. No matter what 2 points you pick on the line, it should reduce to the same ratio. Now for those last two, we can just look at the pictures. We have a horizontal line, that's going to be 0 slope. And for the vertical line, this is undefined or no slope. because it's vertical. And if we tried to do rise over run, even though we have a rise of anything, in this case, these 2 points, it's 1, 2, 3, 4, 5, 6, 7. The run, the x change is 0, and so you can't divide by 0. So that's undefined, or no slope. All right, so there you have finding it from a graph. Just basically count up, count over, and make a fraction. To find between a pair of points, we need to use the formula, which was given to us above. It's the difference in y values over the difference in x values having some lag here. So the difference in y values over the difference in x values between 2 points. And now it doesn't really matter which point is point 1 or point 2, just make sure you start with that for each one. So let's say I make this point 1 and point 2 like this. So our y values are going to be 9 and 5. So that's 9 minus 5. And the x values are going to be 4 and 3. So that's 4 minus 3. It's very easy to get the numbers mixed up here. Just make sure you're subtracting the y values on top and the x values on the bottom in the same order, starting with the same point each time. So this is going to give us 4 over 1, which just equals 4. Looking at the next one, and you can always just start with the second point and subtract back to the first one. It does not matter as long as you start with the same point each time. So I'm going to do 7 minus 3 for the y values and 0 minus negative 2 for the x values. Be careful, we are subtracting here, and so if you have a negative, you're going to have to subtract that negative, which remember turns to plus positive. So we get 4 over 2 here, which does divide out to 2, slope of 2. Or 2 over 1 if you like to have both numbers. All right, next one, 6 minus 6 for the top, and 2 minus negative 3 for the bottom, which turns into 2 plus 3. So we get 0 over 5 here. And anytime you have 0 on top, 0 divided by anything is just 0. So this line would be a horizontal line, and if you notice, they have the same y values, which is why we got 0 in the first place. But 2 points with the same y value would line up horizontally together. So if you see they have the same y value, you know the slope is going to be 0. Looking at the next example, you can maybe see what's going to happen here. Negative 6 minus 5 on the top, and negative 4 minus negative 4 on the bottom. So we get negative 11 for the rise, but on the bottom, negative 4 plus 4, that is 0. And you can't divide by 0, so this is no slope, or undefined slope. And again, they have the same number in the x position this time, which is why we got 0 on the bottom. And 2 points with the same x values will line up vertically with each other, so that is why we have no slope there. That describes a vertical line. Okay, so a really quick overview of finding slope from a graph and from 2 points. Now let's use that information to graph a line given in slope-intercept form. So slope-intercept form is an equation in this form, y equals mx plus b, where m is the slope, so that number would go there. Whatever your slope was would go in front of x, and b is the y-intercept, which is where the line crosses the y-axis. And so the process here to graph a line in slope-intercept form, first you draw a point at the y-intercept. So whatever the b value is, you put that on the graph on the y-axis. Then we use the slope to draw more points, and we'll show you how to do that in a minute. And then simply connect the dots to draw your line. Very simple once you get the hang of it, especially if they're already in slope-intercept form. Very easy to graph a line from this. So y equals 2/3 x plus 4. So again, we start with the b value, positive 4. And that's on the y-axis, so we put a point at 4 on the y-axis. Now our slope is 2/3. That's rise over run, right? Positive 2 up and then positive 3 over. Unfortunately, we're kind of at the top of our graph. But if you imagine going up 2/3, it's the same thing as going down 2 left 3. You can kind of do the opposite of both there. So down 2 left 3 is the same thing as going up 2 and right 3. And if you can only put 2 points on there, that's okay. You can maybe try to estimate where a third point would be, either here or up here. But then once you get your points drawn, go ahead and connect the dots with your line. So there's the line that is given by that equation, y equals 2/3 x plus 4. Let's look at the next one, y equals 5x plus 4. So again, we're starting with 4 on the y-axis. All 4 are they? No. Okay, good. So then our slope is 5. Now, when it's a whole number like this, we know that that is the same thing as 5/1, right? So we want to go up 5, right 1 from that point. Clearly, I don't have enough room to do that. So again, I'll have to go backwards, down 5, left 1. And I have enough to estimate where the next point will be. So there's 3 points we can use. Uh, 2 points is okay, but 3 is always better. So if you can get a third point on there, definitely recommend you make that happen. Do straighter line than that. That's better. Okay. Doesn't have to be perfect, but a nice straight line always looks a little better than a crooked one. Okay, last one here, example G. Y equals negative 1/4 x minus 2. Okay, so again, we start at the b value. In this case, it's a negative 2. And now, since our slope is negative, apply that negative sign to just one of the numbers, and I usually put it on the top one. So it'd be a negative 1/4. So then we're going to go down 1, right 4 for our slope. Down 1, right 4. But you can also go do the opposite. You can go up 1, left 4. And I definitely recommend you do that so that your points go across the entire graph. That way you can get as accurate a picture as possible for your line. Okay, so there you have it. Finding slope and using slope-intercept form to graph a line quickly. Start at the y-intercept and then use the slope to find at least one, but the more points you put on the graph, the easier it is to draw the line.